AC Theory 1. You're probably wondering why we have a DC circuit on the screen right now, because we're going to review a little bit of DC theory before we get into AC theory. So we need to review starting with series circuits. So this is a series circuit, and we're going to solve this, and then we're going to do a parallel circuit. So what we got here is we've got 45 volt source, and we've got 5 k ohm, 10 k ohm, and 7.5 k ohm resistors. So since they're all in series, you might remember we can just add them up. So we can add up the resistances in series. So we've got 5k plus 10k plus 7.5k. And if we add those all up, we're going to get 22.5 k ohms. So now, in order to find the current through the circuit, which is the only thing we don't know, is I. If we take our standard formula of Ohm's law, E equals I times R, we need to solve for I. So if we flip this formula around by dividing both sides by R, then we're going to divide these R's out, and we're going to be left with a formula of I equals E over R. And then if we plug those values in, we've got 45 volts divided by 22.5 k ohms. Make sure you watch your units. That's in thousands of ohms. What we know, though, is that if we're dealing with k ohms and we're dealing with whole units of volts, then when we do this division, we're going to end up with our answer in milliamps. So if we've got resistances in k ohms, voltages in whole units, we're going to end up with currents in the milliamps, or thousands of ohms gives us thousandths of amps. So when we divide 22.5 into 45, we're just going to come up with 2. So this is a pretty simple circuit. Didn't even need a calculator for this one. So we'll go ahead and move on to a parallel circuit.